So when we're dividing expressions with fraction exponents, again, rules still apply. When you are dividing a base value, you subtract the exponents if they're the same. So like for number 16, this is 10 to the first, so I can write 10 to the first as 10 3/3. But if they have the same base, you just subtract those powers. So 3/3 minus 10/3 gives you 10 to the 1/3. And we can't have exponents that are fractions, so we just simply rewrite this as the cubed root of 10. You can have the first power if you want. So then if we're looking at number 15, 15 is not a same base. So this would be like an x and a y because it's 56 and 7. But what we can do is still distribute the 6 power inside there. So if we distribute it to the 1/3 and the 1/6, this becomes 56 to the 6/3 over 7 to the 6/6. So 6 over 3 is 2, so we have 56 squared over 7. So all I would do is say, okay, 56 squared is what? Divided by 7 is 448. We got rid of those fraction exponents. We have our value. We are done. $17, just a regular old fraction, no parentheses. So, A and A. If we're talking in thirds, same thing like we did before. I'm going to make A to the, and the 4/3 it looks like goes to the A. So actually, let's just do that subtraction. So 4/3 minus 2/3 gives us A to the 2/3. This C, because it's negative, needs to come up to the top and become C to the positive third. B is just there. And then let's do the actual division of those coefficients. So 56 divided by 7 is 8. So the only thing I see wrong in my answer here is that A to the 2/3 needs to be rewritten in radical form. So I'll keep the 8c cubed times b and rewrite that a as the cubed root of a squared. So let's do 2 with radicals. Cubed root of 80 over the cubed root of 5. Just like when we multiply, if we can make this go from 2 radicals to 1, we want to do that. So if they're the same, both the cubed root, see, can you divide 80 by 5? You can. You get the cubed root of 16, because you could really put that underneath one big radical as a single fraction. So we get the cubed root of 16. That's not a perfect cube, so if we factor it out, 4 and 4, 2 and 2, we're looking for groups of 3 things. So one group of 2, 1 is left. So this becomes 2 cubed root 2. So that one was with just numbers, but in number 19 it's similar. You just have variables. So what root are we working with? If you don't see one, it's the square root. So we can't divide or combine R and S. So we can't do like 6 minus 18 because they're not the same base. But if we do 2 into each of those powers, 2 goes into 6 how many times? 3. And 2 goes into 18 how many times? 9. Since they both go in perfectly, there would be nothing left to stay underneath the radical. So we would be done here.